Hello, um, welcome to the weekly live session number 10 for the course Affective Computing. Let me start by again briefly introducing about the course instructors. So, course instructors are Professor Janendra Shukla from IIIT Delhi and Professor Abhinav Dhal from IIT Ropar. Um, I am Akanksha. I am the teaching assistant PMRFTA for this course, and I am from Department of CSE, IIT Ropar. So these weekly live sessions, this is number 10th. Hi Kushi, thanks for joining. Am I audible?
Yes, ma'am.
Okay, okay. I've just started with the session, so yeah. And I hope my screen is also visible, right?
Yes, ma'am. Actually, I have a question. Do we have negative marking in this exam?
I'm not really aware about the pattern, but I don't think there will be negative marking. I'm not sure. You should post the question on the discussion forum and the because I'm not a part of the examination team, I'm here for the live sessions, so you should confirm with the examination team. That would be better.
Okay. So, are there any guidelines or something?
uh, all I know that was the pattern is going to be same similar to the assignment questions, so it's mostly going to be the objective kind of questions. Other than that, um, as such, no specific guidelines are for related to the course contents and all, but related to the center, etc., etc. I am not the best person to ask this to. I would suggest you should post on the discussion forum, or you can also mail on the support. I will confirm with the team members if I'm able to, and then I will let you know. In maybe I'll post in the discussion forum itself. I couldn't get you.
Hello.
Hello. Yes, Kushi.
Yes, thank you. That's it.
Okay. Okay. You're welcome. Okay. Let's start with this session. So, in these weekly sessions, if you have not joined earlier, we discuss the problems from the previous year's assignments, which will be helpful for your end term examination as well. And for this week's content, we are going to discuss the emotionally intelligent machines, the challenges and the opportunities involved. So, yeah, let's move on to the first question. And if you are here, Kushi, I would suggest that you try to answer the questions. Please type your answer in the chat box, and then we can discuss. I'll wait for a few seconds, like 10-20 seconds, and then we can move on to the discussion part. So yeah, this is the first. So first 10 questions are usually from the previous year assignment questions. Then rest of the questions are additional questions for your practice. So this is from the previous year assignment. So I'll read the question out for you. It's Moore's law is related to speed of operations in electronic devices, power ratings of electronic devices, level of integration in electronic devices, price of electronic devices. So for those who are watching this recorded lecture, I would suggest that you please pause the video for this moment, and try to answer the questions on your own before moving on to the explanation part. So yeah, let me move to the explanation. So what is Moore's law? Um, it refers to the observation made by Gordon Moore, co-founder of Intel, in 1965. It predicts that the number of transistors on a microchip will double approximately every 2 years. And this observation, let me highlight this. This observation has held remarkably true over several decades and became a kind of principle. Okay, we have to double the number of transistors in the semiconductor industry. While Moore's law is focused on increasing transistor density, so increasing the density also complementing thing is that you try to design as uh, smaller chips as possible. So it tends to result in the um, cost in like cost reductions over time, and also the advancements in the manufacturing processes, the unit cost of sensors decreases, and it is also these sensors become more deployable across various industries and applications. So why are we actually reading about this Moore's law here is that because in affect sensing, in since we are since we are talking about the challenges involved in the domain of effective computing, so what happens is that whenever we want to capture more data, we require more sensors, right? We require more sensors, and what happens is that um, since the sensors are so uh, costly, it becomes really difficult. And of course, if this like the size of the sensor is very like huge, then it is also a kind of difficult to the portability issues and etc. The setup is kind of complicated. So in relation to this affective domain, we would also want the sensors to be as small as possible, as portable as possible, and hence if we want, of course, and the cost should be very low. uh, the reduction in cost can result in more sensor usage, and we can get more uh, data. So the dataset collection thing, it becomes more easier. So that is the purpose of like discussing this Moore's law with respect to our scores. So yeah, um, it refers to the level of integration. It is related to the level of integration in electronic devices. And more level of integration, high density sensors are there, then the cost is also reduced in long term. So that's how it works. Okay, next question. So experience during interaction with affective learning technology is subject to higher variability among learners. True or false? So let's discuss about variability in affective systems. The experience which one person has with the affective system can differ from the other person significantly, because uh, humans are very complex, emotions are complex, and every person thinks differently, every person feels differently. For some people, the some event might be triggering, but for other person that might not be that the case. Okay, so there are so many differences that we have to consider while designing these affective systems, and that is one of the challenges as well, because we can't use just rule based systems, because these rule based systems cannot cover all the permutation combination which are possible, right? So sorry. So first is individual differences. Um, every person is different. They have diverse cognitive abilities, learning styles, preferences, and emotional states. As a result, the experiences with effective learning technology can differ based on how well the technology aligns with their individual needs and characteristics. If a person is feeling good interacting with some effective agent, then they might want to go back again and again and interact with that robo or what that agent. But same agent, when it is interacting with another person, that person might not be feeling good. So it depends on your individual differences, your cognitive in the case of say some tutors which are there, like auto tutors, and they have these affective component as well. So that is one thing. Then comes the emotional responses. Effective learning technology, it aims to adapt to learners' emotional states and responses, because emotions, one person might be feeling certain emotion at certain point of time, right? um, I'm If I'm in a good mood, I would want to interact with that robo in a certain way, that the robo should also respond like that. If I am sad and I am frustrated, then the robo should not play upbeat songs, like, or maybe to counter that it can play, but it should respond accordingly. It should ask what happened. So it's something like that. The responses should also be tailored according to the emotional responses. So these factors are very important to have a good user experience, because we need to consider all the differences. Another one is engagement levels. So learners, when they are interacting with some agent, some maybe online auto tutor, the level of engagement can also vary. It's not the case like one person will be just looking at the screen all the time, and it we will consider the person is very engaged. Even if I'm looking like slightly like on the side, but I'm not looking directly on the screen, I might be engaged. But yeah, we also need to consider the different engagement levels, or how motivated that person is to look at the stimuli or the content being presented, so we can adjust the responses by the agent accordingly. So let's read this out again. Based on factors such as motivation, interest in the subject matter, and perceived relevance of the learning materials, this variability can influence the overall experience and effectiveness of technology for different learners. Now, then comes the contextual factors. This environmental factors such as learning environment, social interactions, and external distractions can impact learners' experiences with effective learning technology. Variations in these contexts may be a thing which is acceptable in one society might not be acceptable in another society. For example, certain things are considered good in say US, but they might not be considered good or polite in Indian context. So we need to include what the context information as well, in addition to the objective parameters. Okay, so let's move on to the question once again. Experience during interaction with effective learning technology is subject to higher variability. Of course, the number of people that technology is interacting with, the more variations will be observed, and the better the understanding will be. So we want more and more people to participate. Okay, so that is true. Third question. So auto tutor is one of the first reactive conversational intelligent tutoring systems reactive conversational intelligent tutoring systems which can detect boredom and confusion but not frustration. So let's talk about auto tutor. So there is this um, software, there's this agent developed by this was developed for like tutoring purposes in the domain of Newtonian physics. Okay, so it's an intelligent tutoring system that helps students compose explanations of different concepts in Newtonian physics, enhances computer literacy and critical thinking by interacting with them in natural language. So I'll show you in a while what is the interface of this effective auto tutor, and in previous lectures we have also discussed this. But what it does is that it can interact you can interact with that agent in natural language. You can, like we do with chat gpt example, we write it, hey please give me this explanation of this, also provide me some the correct answer out of these four options. So you're writing this in a natural language, right? How we converse with other humans. So we can also converse, have conversation with the agent in natural language. So in natural language with adaptive dialogue moves similar to those of human tutors. So it the aim is to mimic the human tutor. Okay. If you're not able to understand something, you will type and then it will respond accordingly. It can explain it again, or these things are there. Now, autotutor constructs a cognitive model of students' knowledge levels by analyzing the text of their typed or spoken responses to its questions. Now, suppose if the answer is correct all the time, then it can understand that the student is sharp, like they are paying attention, they are in the right state of mind, they're not frustrated, they are performing well in the tests. So you can have a kind of generate kind of a report, or um, the characteristics of the learner you can observe, right? So you can develop a cognitive model, how the brain works of that person. Um, then by analyzing the typed responses or like that, and the model is used to dynamically tailor the interaction towards individual students zones of proximal development, how individual students can benefit from, because what happens is that there's a human tutor. He's teaching all, suppose it's a class of 100 students. Now he has to teach 100 students. The teacher, it's impossible for him to cater to each and every student's requirements specifically by understanding the states and all. Even if a teacher tries to, it's very difficult, it's almost impossible. But with auto tutors, there's a one to one conversation. So one to one, what happens is that the agent can understand, the tutor can understand my mental state, my emotional state, and after that it can design its responses or its pace or the course contents according to my level. So it is very tailor made for me. So it is an individualized instruction and human-like interactivity to a new level by automatically detecting and responding to students' emotional state in addition to their cognitive states. Cognitive and emotional, what's the difference? Again, cognitive means how am I able to answer the question, the technical part. I'm like thinking and developing some answers, constructing some answer in my mind, and then I'm writing it down. That is the cognition part. If the answer was option A and I'm giving A, then that means okay, I'm paying attention and my mind is working fine. I'm able to understand the concepts. However, if I'm not feeling well, like emotional part is I'm feeling happy or I'm feeling frustrated or I'm feeling sad due to some reason, that the tutor might sense it. Different senses are there, so we can sense the emotions and then it can respond accordingly. Okay. So it uses a decision level fusion algorithm where each channel, which is, there are three channels, which is conversational, cues, face and posture. So body posture, facial features, facial expressions, and then conversation, whatever you are typing. So these three modalities are there, which can help the affective auto tutor to understand your state of mind, how you are behaving right now, and it will adjust the contents of the course or the pace of the tutorial accordingly. So yeah, these are combined with an algorithm that selects a single effective state and a confidence value of the detection. It can sense the frustration part as well. So yeah, it can sense. So coming back to the question, okay, let's see the how it is working. So yeah, so this chair, there is some body posture measurement system. This is one modality. Then there is a camera sensor which can capture your facial expressions. You see, eye tracking is there. This facial features, other like you can also capture the facial action units. So yeah, there's a template matching thing happening. Then this is the auto tutor part. There you can see an avatar. This is an avatar here, and there is explanation going on, and then there is a window for the typing with that the tutor is asking you some questions and you need to type the answers. Okay, and then there is a log, how person is performing, and these things when they are combined with each other, these three modalities, one, two, and this three, so these three can be used to tailor the contents for the given that person. So yeah, this is false because it can detect the frustration part. Okay, another one is there which is called gaze tutor. So gaze tutor is a multimedia interface consisting of an animated CA. So what is CA actually? It's the conversational agent, I guess. So this is conversational agent. Let's see what is gaze tutor. So, okay, Gaze Tutor is an intelligent, again, it is also similar to Auto Tutor. However, the modality that it is working on, it's different. Okay, so it is an intelligent tutoring system, ITS, you can call it. It aims to promote engagement. The end goal is also slightly different. It aims to promote engagement and learning by dynamically detecting and responding to students' boredom and disengagement. The tutor uses a commercial eye tracker. So there is eye tracker, since gaze is like eye gaze we are using, right? To monitor a student's gaze patterns and identify when the student is bored, disengaged, or is zoning out. So what it can do is, suppose you're attending a lecture on gaze tutor, there is a camera sensor which can capture your gaze direction. Ideally, you should look straight onto the screen. However, if you are distracted and you are like sitting like this, your eye gaze direction will be in that direction, right? What will happen, this gaze tutor will sense it that you're not paying attention to the screen. It will raise some kind of alert or some kind of intervention that, oh, Akanksha, you need to look at the screen, and why are you getting bored, etc., etc. So there can be multiple responses, right? So it can alert the student that, oh, you are getting bored now, you should pay attention, the lecture is still going on. So it's like that. So it attempts to re-engage the student with dialogue moves that direct the student to reorient his or her attentional patterns towards the animated pedagogical agent embodying the tutor, like the agent, okay, the avatar. So gaze tutor is like it uses the gaze modality. So this is the interface. You can say, you can see, this is the avatar or the person like speaking. This is not an avatar actually, but the video is going on here. So um, you should actually pay attention to this region, right? if you are if you are not paying attention here, and if you're paying attention to the other regions here or out of this area, then um, it can detect, and then, hello sir, thanks for joining the session. Can you please mute? Okay. So we are discussing the week 10's content, which is the challenges and the opportunities involved in this emotional intelligent machines. So we were discussing this question, which is the gaze tutor. Okay, so the gaze tutor is one intelligent tutoring system. So the interface of gaze tutor. I'll repeat briefly that um, whenever you are interacting with this intelligent tutoring system, the student is there and it observes the student's activity through a camera sensor, and then the facial features can be captured. And facial features specifically for gaze tutor, it is the eye gaze direction. Now eye gaze direction, if the student is paying attention to the lecture, the eye gaze should be straight, looking onto straight on the screen. However, if the student is distracted, then what you can do is that whenever there is a gaze direction like deviating from the desired target, then you can raise an alarm or alert like, okay, you need to pay attention, you need to pay attention to the lecture, it's still going on, you can intervene in between. So that is how this gaze tutor works, and the goal is to monitor a student's gaze patterns, and we want to detect and respond to students boredom and disengagement. We want them to re-engage with the content, right? And yeah, towards the animated tutor or whatever the video, the content is playing. So that's how this is working. And this is a screenshot from the gaze tutor interface. So yeah, moving back to the question is, uh, it is it is not a multimedia like interface. Gaze tutor is a multimedia. It's not an animated CA. It's like this uh, human lecture going on, right? So it's not an animated CA. So this is false. But yeah, we are monitoring the gaze here. Okay. Next question is, level 0 adaptation systems recognize that the performance of a particular task could be optimized according to some metric, but no adaptation is performed. So true or false? So take your time and read the question. Okay, I'll move on to the explanation now. So there are different levels of adaptation. What it means is that uh, if there is a human and there is an affective agent can be any system, any affective system that we are interacting with, right? Now, according to how the main purpose of affective systems the main purpose of affective systems is that we want to respond in a more human like way, like it should be less robotic and more human like, right? So in order to achieve that, we need to adapt the responses of that agent according to how the human is feeling, because we want to respond accordingly to the situation that we are in right now. Now there are different levels of adaptation for that. One machine, for example, the agent can be Alexa, it can be um, any music speaker like we discussed, Shimi, any other robo, any auto tutor. So they any these affective systems, anything can be an agent. Now this agent can adapt accordingly. If what is the purpose? Suppose Alexa is a conversational, like this is like that, and uh, if we are like, I'm telling Alexa play this, and it should sense like, is it adapting to how I am feeling right now? If I am happy, then Alexa should respond accordingly, and if I'm feeling sad, then Alexa should respond accordingly. But it does not happen, right? So some agents can be more predefined, hardwired, you can say. They just follow the rules, and then they play the that whatever the command you've given, right? So there is no adaptation according to how you are feeling. So there are different levels. Let's see one by one which level corresponds to which adaptation. Level 0 is no adaptation. Level 0 is no adaptation. The system does not alter its behavior. The system does not alter its behavior in response to the user's emotional state. Traditional vending machines that dispense products without considering the user's emotional state. For example, another example can be Alexa. If you are just telling Alexa, play this song, then no matter if you say this in a sad tone or a happy tone, it's the same for Alexa. It won't change its response, it will just play that song. So there is no adaptation. Okay, traditional vending machines are also there, they will just dispense. Okay, now second is level 1, which is recognition of need of adaptation. Like the system recognizes the need of adaptation but does not perform any adaptation. We can capture the data. Okay, I'm feeling sad, I'm feeling angry, I'm feeling happy, but it's not adjusting the contents, it's not adjusting its contents. For example, if there's an ITS, which is which can detect using different sensors, it can detect that the student is frustrated right now, but still it's just showing the same video, it's showing the same video. So it's just the detection part and it's not working on that part. That is the level 1 adaptation, where there is a need for like recognition of need for adaptation. Okay, so then comes level 2. Level 2 adaptation means single task adaptation. um, what it means is that there is a single task that the system is performing, and then it is adapted to optimize that specific metric. For example, this for example, there is a conversational agent. Say you're you're chatting with a like chat box, the chatbot is there, right? So you're writing your response. Okay, I'm feeling sad today. So it will respond. Why are you feeling sad? There is just one modality involved here, and there's just one thing that the agent has to do. It has to make the conversation more emotionally aware, right? So it can adjust its responses. If you type, yeah, I'm so happy today, then it should respond, wow, what may I know what's the reason for your happiness, or maybe you would like to share with me. If you are sad, then it can tailor its responses like that. If you are feeling angry, then it should calm you down like that. It should tailor the output that next text you are receiving. It should tailor that according to how you are feeling right now. So yeah, it is a single task within the system is adapted to optimize a specific performing metric. This in this case, the performance metric can be like um, the customer satisfaction, right? The customer satisfaction, engagement, these kind of things we can um, look for. Then it comes the level 3, which is multitask adaptation. Now, it is just one step ahead of level 2. There are multiple tasks which are adapted simultaneously to optimize performance. For example, there's a adaptive learning way, then the system that we discussed, like affective auto tutor. So it captures the information from different modalities. It knows about your affective state, it knows about your behavioral, the cognitive state as well, the cognitive as well as the emotional awareness is there. Then it can rearrange the lessons. For example, if the student is finding the lecture heavy, very heavy, on like there's so much load, um, then uh, for example, there's a maths heavy lecture that the student is very confused right now, you can then switch on to some other subject which is lighter, which is like maybe environment or something like that, the more theoretical, less mathematical, so that the load becomes lesser and the student can perform better. So this is one modality. Then the other thing can be like the videos which are being played. Suppose they are being played very fast, but you can slow down and you can give the student more breaks in between, more time to answer the question. So these things can be there. Like I should note it down. So one thing can be like decreasing the pace of the lecture, uh, increasing the duration of breaks, right? What else? Changing the content like order, changing the content order, or so these changes can be made. Next is level 4, which is which involves not only a single agent but also involves multiple agents. How is that? Like, what is this? This is multiple independent agents, multiple independent agents or services. They communicate and coordinate adaptations to enhance user experience. Example, there's a multiplayer video game, then different characters are there. One is mine avatar and one is your avatar. Then we can adapt the behavior and interactions based on the emotional state of the player. Okay, coordinating to provide a cohesive and engaging experience. So we can modify not only my response, but the other person's also. So this is level 4. Okay, so question was, level 0 adaptation systems recognize that the performance of a particular task could be optimized according to some metric, but no adaptation is performed. This is false. What was this level? This was recognition for need for it. This is level 1. This is not level 0. Okay. Okay, next question. Affective states can be monitored using behavioral data, sensor data. So A only, B only, both A and B, and none of the above. Sir, if you would like to answer, you may please write the answer in the chat box. So I'll move on to the explanation now. Um, Affective states can be monitored using both behavioral data and sensor data. What comes under behavioral data is that it refers to the observable actions and responses that indicate an individual's emotional state. Okay, observable actions and responses that indicate individuals emotional state. Example, you can, if a player starts smiling and laughing while playing, then they are experiencing positive emotions such as joy or excitement. So a student becomes visibly frustrated or agitated while attempting a task, then indicates negative emotion like frustration or stress. So we can observe their body language, their, you know, how they're behaving, their head nods. So this kind of modality comes under the behavioral data, right? And specifically the sensor data here, it means that um, this physiological signals like this EEG, maybe ECG. Um, there are skin conductance levels as well. So different sensor data can be. We will see the sensor part now. So sensor data involves capturing physiological signals, as I mentioned, like physiological signal, bodily responses to infer emotional states. This can be heart rate variability, skin conductance level, or facial expressions to assess the emotional responses. Example, in case of a fitness tracker, if the wearer's heart rate increases, it may indicate feelings of exertion or determination. Like, okay. And then there comes facial recognition technologies. There it can detect the expressions like smile, frowns, or raised eyebrows, and we can associate with the corresponding emotion that we are currently going through. So both are correct, both A and B. Okay. Affect Detection generalization is a very challenging problem because there is inter-user heterogeneity. Okay, true or false? What is inter-user heterogeneity? As the name suggests, between users we can observe a lot of differences because we are humans. Humans are not like we are very different from one another. So how we respond to different of to the same situation, same stimulus, it will differ a lot. So there is a high variability in that response, especially when these things like emotions, they don't have very well defined explanations, right? They're little vague in the sense that there is no hard rule for that. If a person is feeling happy, your happy and my happy can be very different. So it refers to the variability or differences among individuals in how they express and experience emotions. This this can manifest in various ways. Differences in personality traits. How does that, you know, come into your personality? It's because your personality you're born that way. Like the cultural background was that. Past experiences have not been good or bad, or they have been, good maybe. And physiological responses, because if you are you came back after running for like 10 kilometers, then your body might be behaving differently, right? Then it might not be the very normal response that you will expect from a person. They might behave differently. So yeah, this detecting and generalizing these affective states, it becomes very challenging because one what may indicate a particular emotion in one person may not hold true for another. We know these things, like we this is exactly like again, so much differences. So there is no hardcore rule like if this is happening then this is happy, if this is if the person if is subjected to a stimulus, they will laugh only. No, it's not the case. Example, um, imagine a scenario where we a system is designed to detect students engagement levels during an online lecture. Now, the system is capturing your facial expressions, body language, and physiological signals to infer students' emotional states. However, it encounters challenges due to inter-user heterogeneity. How can that be? Facial expressions. Some students may display subtle facial cues. Maybe I'm not that expressive, and I'll just, if there's a funny situation going on, I'll just laugh like, smile like this slightly. But one person, other student, they can laugh out loud. So, yeah, they can be differences, like when they're engaged, slight smiles or nods, while other may exhibit more pronounced expressions. Then cultural differences can be there. Some cultures, it's considered rude to be more expressive like that in the public. So yeah, that is also one thing. Then comes the body language. It differs very significantly. One student may lean forward and makes frequent gestures while actively participating, and while one student like I would prefer sitting just my chair stable and then maybe raising a hand and more subtle body language. So we should account these. We can't say that the person is not showing certain movements, so he's not engaged. Physiological responses can be there, like if heart rate, skin conductance, and pupil dilation, they can also provide valuable insights. However, they can also vary, like age, fitness level, health conditions. We don't know the background, so a lot of possibilities. A student who is physically more fit may have a lower heart rate compared to the sedentary, making it challenging. So yeah, cognitive factors can also be there, like attention span, learning style, prior knowledge contribute to inter-user heterogeneity. While one student can quickly grasp, other can take some time and struggle to concentrate, while so there can be differences in that sense. So yes, affect detection is highly challenging in that sense. We can't generalize. Okay, shimmy is an example of level 2 adaptation. Shimmy, if you remember, we discussed about this robo in the previous lecture as well. This is shimmy. Shimmy is also called Travis now. Travis is a robotic smartphone speaker dog and a music listening companion. Um, okay, so if we look here, you can place your phone here, and then um, this is the leg which it taps on the ground on the table according to the beat of the song playing. So it is essentially you can consider it as a speaker, but it is a smart intelligent speaker in the sense that it can also there are this projection sensors. It can also project light in your room, so it's like a music buddy. So you will play some song, it will detect the tempo, so it will just like so it will do like this and tap its this leg like that. So it's you can check this video on YouTube. um, so it is it can detect your emotional state. Okay, um, it is kind of a companion for your music journey, but it detects if you're feeling sad, then it might play some good uplifting songs, and if you're feeling low, then it might play some motivational. So it can adjust its output according to how the user is feeling. So it follows. We'll see which level of adaptation it follows. So it's a entertainment robot, serves at both as an amplified speaker dog and socially expressive robot. It is designed to enhance a human's music listening experience by providing social presence and audience companionship, as well as embodying the music played on the device as a performance. So yeah, this is a level 2 adaptation where so level 0 was no adaptation. Level 1 was it is adapting. It is recognizing but not adapting. Level 2 is adapting, and it is doing a single task. Okay, so single task is there. It is adjusting the music according to that. There's no other thing it's adjusting. So level 2 adaptation, yes. Okay. Understanding a player's affective profile will not help in enhancing the game experience. This is this is false, because if we can know how the player is feeling, then in online gaming or effective like gaming systems, we can detect and we can modify the contents, the game structure in order to make it more interesting for that particular user. So how can we use in this context? It can significantly enhance. The end goal of effective system is to enhance the user experience. For that, we want different affective profile. Um, for me, it should behave differently. For you, it should behave differently. In case of gaming also, so personalized gameplay can be there. Like understanding a profile's affective profile, they can personalize the gameplay experience to match. For example, um, if if a player enjoys challenges and competition, the game can dynamically increase the difficulty level, right? And if a player prefers more relaxed experience, you want to relax, the game can adjust the pace. More relaxing environments should can be provided, right? Then adaptive challenges are there, like it allows game systems to adaptively adjust the game's challenges based on the player's emotional state. If you're not feeling good, might be some simple game which you will probably win and you will feel better. So like that, if a system detects boredom, it can decrease the difficulty. If you're unable to perform well in the game, then you might feel bored, so it can decrease the difficulty level or offer hints to assist the players. We can show hints. If the player shows a excitement or engagement, the system can introduce more challenging tasks. Then there can be tailored feedback and rewards, like understanding it enables to provide us more rewards and these feedbacks which are tailor made for the person, for the player. So positive reinforcement such as rewards, achievements can reinforce desired behaviors and enhance the player's enjoyment. And the game can offer supportive feedback or encouragement during challenging moments. So yeah, then dynamic storytelling can be there. Adjust the game's narrative, how the game is going, how the story is being presented. It can also be uh, adjusted according to the user. Now, branching storylines. There are also like games like interactive games. You decide what happens next, and then the game works like that. So yeah, it can plot twists, etc. So creating immersive environments. Um, Ambient music can be there, lighting effects can be there. There might be a setup where the gaming setup is there, so you can adjust the lighting if you're it's very intense, so maybe red lighting is there. If it is more fun, then multicolored lighting can be there. So it can be changed according to how the user is currently behaving, so it will enhance the overall experience. So this is false, of course. We should actually have this profile, affective profile. Okay. Cameras can be used to monitor the heart rate of a user. So yes, when we talk about these sensors, usually what happens is that these sensors which are for medical, like not medical but physiological sensing signals, they are slightly expensive and they require specialized setups. Whereas, um, what if we want to collect more and more data and we don't want to use these sensors? Can we replace the sensors with some other sensors which are cheaper and much readily available in the market? So that's when they started exploring this camera sensor for this heart rate monitoring. So it sounds very weird, but this one paper was there which they found a way which is called RPPG, which is remote photo light. Photo means light plethysmography. So RPPG. So it can be used to monitor the heart rate of a user through technique. This is called RPPG. It relies on analyzing subtle changes in skin color caused by variations in blood volume in the microvascular bed of the skin. Very fine detail which occur with every heartbeat. So they observed that some certain changes are observed every heartbeat, every pulse. You can capture that. So by capturing the video of users' face, particularly regions with good blood perfusion such as forehead or cheeks, and using specialized algorithm to analyze these color changes over time, it's possible to extract the user's heart rate non-invasively. Very important, like usually people won't prefer invasive sensors which need some needle or sticking on your scalp, which can be very uncomfortable at times. So we usually prefer, okay, if there's a camera, if there's a webcam recording my video, I won't mind that much. Of course, if I have given the consent for that, but otherwise it becomes you have to be in the same position for a while in order to keep the sensors um, stay at the place. So other might be very uncomfortable. So coming back to this, yeah, so we can use the camera sensor. This is how it kind of, this is an overview. So firstly, the region of interest is detected. This region of interest is detected, then you can capture the RGB channels or different skin segmentation can be there. This area can be observed. Then this is RGB channels, and then you can observe some patterns. Okay, then pulse rate estimation can be there. So it's like 70 BPM. It's detected like that. So this is one brief overview of the methodology which the paper proposed. So yes, the answer is true. How many modalities does the affective auto tutor system track to detect user users emotional states? We discussed about this auto tutor. Affective auto tutor, what it does is it is an intelligent tutoring system, which means that you are attending some explanation or lecture or tutorial. There's an avatar, there's an avatar which is interacting with you. Now you can type the responses. They like they respond in form of text. Okay, please answer this question, and then it will show on your screen. Then you will you will be able to type as well. Then there are other modalities. Let me go back to the slide. There was a slide. Yes, this one. So affective auto tutor, what it does is that here you can observe that it captures the body posture through sensors on the chair, etc. Then there is a camera sensor which can do the eye tracking thing, and then there is interaction through keyboard like input, text input. So you are this is if so this thing, this is the question which is raised by this avatar, and then your response is written here. You have this conversation with this um, this avatar. Then the log information is stored here. Okay, this is the logs. So there are three modalities here. Yeah, so we have three modalities. First is the facial expressions. No, it's not speech actually. It's body posture. It's wrong. This is facial expressions or gaze. Okay. Then the body posture, and then conversational interaction patterns or conversational patterns. So yeah, these three modalities are there. Yeah, you can see it was here only. Okay. There is body language. This is body language. This is contextual cues, and then there's facial features. This facial data is being captured. So three modalities. So what is the primary objective of the gaze tutor system? To track users' emotional state, to monitor users' attention and provide interventions, to display multimedia content for educational purpose, to analyze users' body language during interaction. So we discussed about gaze tutor. It is again an ITS which aims to promote engagement and learning by dynamically detecting and responding to students' boredom and disengagement. Whenever it senses that you're not interested and you're looking away from the screen, it will raise an alert. So it uses a commercial eye tracker to monitor a student's gaze patterns and identify when the student is bored, disengaged, or is zoning out. Then it attempts to re-engage the student with dialogue moves that direct the student to reorient his or her attentional patterns towards the animated or the person in the tutorial. Okay, it is not conversational. There was a question which uh, asked, like, there is a conversational agent. It's not a conversational agent, it will just raise an alarm. So you're not chatting with that. Okay, the conversational agent is in or affective auto tutor. That's why it was false. So again, it can be, it's very intuitive that gaze reactivity positively influence learning gains. If you are intervening, like, if you are alerting me again, like, oh, you seem to be more disinterested, please pay your attention here, I will focus here again. I will probably focus here, and then it actually helped students to learn in a better manner. So this was a very major advantage, was to direct disengagement repair. So you can work on that. This is taken from the paper, and this is the overview. Like, there's this student, then there's gaze. If gaze is assessed, if there's any issue, like gaze statement is there, um, text is there where we are answering the questions, then the feedback is there, then it goes to the tutors, tutor question, tutor output, direct instruction is there, then script is there. So a lot of stuff going on. But the crux is that uh, it mostly uses the gaze modality and provides interventions. So B option is correct. Okay. What challenge arises when incorporating context and appraisals into effective computing models? Lack of sensor availability, difficulty in modeling, cultural differences, transient emotions. We need to select the most appropriate option here. So, what exactly is incorporating context and appraisals? Context, we know the um, it's not directly present, but the other information, additional information, which can impact our, the target variable, you can say. So in effective computing models, we uh, context is very important, uh, because we don't know how, if the person is feeling sad, if we know the reason why the person is feeling sad, or is it the environment, or is it something happened to him, then we can tailor our responses accordingly, and respond in a very better, much better manner. So in context of this effective computing, there's a challenge of this difficulty in discriminating between the models. The context is, I mean, in context of effective computing is appraisal. It refers to the cognitive process through which individuals evaluate situations or events based on their relevance, goals, needs, values. So we'll understand this with the help of an example. If a player in a computer game, it perceives a particular game level as challenging but achievable. So appraisal of controllability and compatibility with goals, they might experience excitement or determination. He thinks that this is tough, but I can do it. However, if they feel like like the level is very challenging for him, and it's very overwhelming, then impossible to conquer, they might experience frustration or anxiety. So it's like appraisal in that sense. Contextual factors, they play a significant role in shaping emotions, but we need to include them, but it only adds to the complexity. What happens is that, as we discussed in a previous question, that like incorporating the variability between the individuals, every person behaves differently. We are unable to have a hard code for that, a rule book key. If this is happening, then it corresponds to this. Without incorporating the context information, it's not the correct option. But if we add the context information, it's so huge, it will be different for everyone. We need some concrete method to incorporate that in our models. It adds to the complexity a lot. So different individuals may interpret the same context or appraisal differently, leading to variations again in emotional responses. So accurately modeling that, like how are we going to model that, how are we going to construct the approximate rules, if not the very exact rules, how are we going to achieve that? That is very difficult. That is a huge challenge. So difficulty modeling is the right option. Okay, so how does a level 1 adaptation system differ from a level 0 system? So we've studied about this. It performs adaptation based on emotional states. It monitors the emotional states but does not recognize the need for adaptation. It recognizes the need of adaptation but does not perform any adaptation.
Let's see.
Yeah, it recognizes the need for adaptation but does not perform any adaptation. And D, it relies solely on the predefined interaction scripts. So, yeah, again, we will again discuss with the help of example. If we have a smart speaker at our home and it can detect users' emotional state through voice analysis. However, it is hard coded. The system is programmed with a fixed set of music playlists and recommendation that don't change based on my emotion, my mood. So if the user is feeling sad, it will continue playing the same generic music recommendations without any adjustments. This is level 0 with no adjustments, no adaptation. Then comes level 1 adaptation, where the smart speaker is there but upgraded to a level 1 adaptation. In this scene, in this scenario, uh, the system not only detects but also recognizes the need. So if the user's voice indicates sadness, the system understands that offering upbeat or cheerful music might not be suitable because the person is not feeling that good. So it understands, might not adapt to that, but it recognizes. Okay, so C is the right option. Okay, what metrics or indicators might trigger the recognition of a need for adaptation in level 1 system? Changes in user's voice or other modalities, alterations in system behavior based on emotional cues, predefined interaction scripts, no consideration for emotional states. Okay, so again, for level 1 adaptation, the recognition of that, recognizing that there is a need of adaptation, it involves monitoring various indicators related to users emotional state. Now this can be users voice tone, speech pattern, facial expressions, or other modalities. It depends on what kind of agent you are using, you're interacting with. If it is Alexa or Siri, then uh, then you can say that this voice sound patterns you can observe. If there's some auto tutor, they can recognize your facial expressions. If you're feeling like confused looking at the screen like that, I didn't get it, maybe there's text. So depends purely on um, the type of agent you're interacting with. So for example, if we talk about voice, then a sudden shift in voice pitch or slower speech rate might indicate sadness or frustration. By tracking these changes, the system can trigger adaptations to better respond to users' emotional needs and enhance the interaction experience. So, in out of these options, this user's voice or other movements.
Yes, correct.
Yeah. Okay. What distinguishes level 2 adaptation systems from lower levels of adaptation? They rely solely on predefined scripts. They adapt on random changes. They optimize performance metrics based on emotional states. They ignore the user's emotional cues. I'll wait for a few seconds. You may please write the options in the chat box.
B or C?
B,
C. C.
C. Okay, okay.
It's B or C.
Let's see.
Okay, C.
Okay, so if we talk about these again we will use some examples. Consider a virtual tutor, which is basically intelligent tutoring systems, ITS. We have discussed this multiple times now. It is used to designed to assist students with their studies. Now, this virtual tutor, it employs effective computing to recognize and respond to students' emotional state during the learning sessions. If I'm um, feeling confused, it will sense and it might stop for a while, give me some time to think. It can display a message. Okay, this is take your time, just like, so it will be more interactive and it will not be just pre-recorded lectures, right? So yeah, so level 0 adaptation will be no adaptation. In this case will be the virtual tutor may deliver pre-scripted lectures lessons without considering the students emotional states. It follows a fixed sequence. If there are lecture number 1, 2, 3, or maybe subjects are there like one subject, two subject, three subject, which is maths, environmental studies, or English, right? So the sequence is also fixed, okay, regardless of whether the student is engaged, bored, or frustrated, or excited, etc. The system does not recognize the need for adaptation based on emotional cues. This is level 0, no adaptation. Then comes level 1, which is the basic adaptation, which is the recognition actually. Again, let me write recognition, but no
No, it's two then. Level 2 is this optimization. C is correct.
Yeah, C is correct. Because we are not doing it randomly. We're doing
Yeah,
based on the
yeah.
emotional cues.
Hmm.
Yes, yes. So again, I'll have to read this. Anyways, if the student displays signs of frustration during a challenging problem, then the system might continue with the same instructional approach without adjusting its strategy. It's sensing that there is frustration, but it's not adjusting. Now comes the level 2, which is adaptation, single task adaptation. Okay, single task adaptation. So, in contrast, what level 2 will do is that the virtual tutor detects the student is feeling overwhelmed. It can adjust its teaching approach to provide additional support or personalized guidance, maybe simplifying explanation, maybe repeating the explanations, encouraging messages. Okay, you're doing very good. You might be displayed on your screen. Good job, or something like that. And you may also alter the pace maybe of the, okay, you may slow the video down so that the person gets more time to grasp the content. Then, okay, level 3 would be, we'll discuss in a while. So yeah, C is the correct option. Okay, now level 3 question. Which of the following is a characteristic of level 3 adaptation in affective computing? Adapting only predefined behaviors, focusing on a single performance metric, adapting multiple tasks concurrently.
It's C.
Sorry,
C.
C. Okay, D is ignoring user feedback. This is the level 1, level 0 for sure. And we just discussed this is level 2. So yeah, okay. Now what will be level 3 example? Again, same example continued. uh, to help student to learn maths, there's this intelligent ITS, and it not only tracks the emotional state, adapts to various tasks. Like in level 2 we were discussing, it will just do one thing, it will adjust, maybe, okay, not even, like it will display just the message, you're doing good, you're doing good, but it is not adjusting its contents, it's just doing one thing at a time. But level 3 adaptation, what it does is it can adapt the content. So it might adjust the difficulty level of math problems. It's easier should be given, if the person is feeling overwhelmed, then you might provide them some simple problems to solve. Then the confidence will be there, they will feel better. Now, if the system detects frustration, it can switch to more challenging if the student is feeling bored. Same. Now, teaching style adaptation can also be there. In addition to adapting the content, it can modify its teaching style. It can slow down. It can um, switch to a more supportive and encouraging tone. The tone can be changed. That's also very important. It can be more polite, like that. So, to alleviate this anxiety and promote a positive learning experience. Now, there's feedback adaptation. Uh, the system can adapt the frequency of and the type of feedback provided to the student. Um, for example, if you are after every question you are saying, "Oh, you need to improve, you need to improve, you need to improve," then the person will be very discouraged. But uh, it in converse is like, if you are want to cheer them up, or if you want to motivate them, you can do it for every, after every question, even after a simple question, you can display this message like, "You're doing great job, great job." So it will actually enhance it. So negative things we want to reduce, and positive ones, feedbacks, we want to increase. So yeah, in case of this negative feedback, there might reduction in corrective feedback, and instead offer more positive reinforcement to reinforce learning progress. So yeah, here we are dealing with multiple tasks concurrently. Now comes level 4. Which of the following statements are true? Level 4 adaptation involves the coordination of multiple independent agents or services to optimize user experience. In level 4 adaptation, communication between agents allows for collaboration adaptation across different tasks and processes. Level 4 focuses on adapting individual tasks independently without communicating between agents.
Who is it a must? Who is must? Then let me check one also. Coordination of multiple agents to yes, yes, one and two.
1 and 2.
See, I think so.
Okay. So, yeah. Level 4 is one step ahead of level 3. Now, level 3 was multitask, but level 4 is multitask is there, but then more than one agents are involved. Multiple agents are involved, multiple independent agents or services to optimize the user experience. It means that different agents collaborate to adapt various aspects of the user experience. Uh, this communication between the agents is allows for collaborative adaptation across different tasks and processes, enables to share information and coordinate their adaptive behaviors to achieve same thing. It does not focus independently. Actually, this is with respect to the options given. That's why it's repetitive. Without communication between agents, it's not the case. It emphasizes collaborative adaptation. So 1 and 2 are actually correct, because in the option 3 they say independently without communicating, which is false. Okay. Okay. What are the two kinds of empathy with respect to how an empathizer responds to the user? There's an empathizer. Empathizer is an affective agent which will respond
It's
accordingly. Yes.
C, C, C. Cognitive and affective.
Okay. Okay, let's see. So this is actually
Parallel is also there, I think.
parallel and reactive. If we talk about this empathizer in context of empathizer, so
Okay.
I think cognitive is like related to, yeah, the thinking process, and affective is also there, um but
So two types, as far as types are concerned, then it is
yeah,
parallel
parallel
and
and reactive, because uh, see,
parallel and reactive.
there's an agent, it has to decide how it is going to respond,
Hmm.
right? So that is parallel and reactive. So let's see what parallel and reactive actually means. Parallel, as the name suggests, it's parallel to what the end user is feeling. So it involves mirroring or aligning the emotional state or the behavior of the user, right? In this approach, the empathizer or the system, it responds to the user's emotional cues by reflecting similar emotions or behavior. Okay, the goal is to create a sense of emotional resonance or rapport with the users by demonstrating understanding and empathy, even like in the therapy sessions. And in this therapy sessions, what happens is that initially the counselors, what they do is they want to interact, they want to make you comfortable, and that's when they kind of want to relate to you, relate how you're feeling. So if you feel like, okay, um, I am feeling sad, I've been through something, then if the person also says, oh, I have also been through a similar situation, you feel more comfortable around them. Similar thing is happening here. Some situations require the agent to react in such a manner that however the person is feeling right now, or that the the person is feeling, we also want to respond in a very similar way. But it's not always the case again. But let's see an example. If a user expresses sadness, then if a system is exhibiting parallel empathy, it might respond with a compassionate tone, right? So there are again two ways. If somebody is your friend is feeling sad, there are two ways. You will see, oh, what happened, are you fine? And then another way can be like you do the exact opposite, you play upbeat song, they want you, oh, come here, don't worry, like that, in a cheerful tone. So the first one is parallel empathy. Then sympathetic gestures are comforting words to match the user's emotional state. This mirroring helps validate the user's feelings. It gives us validation and it fosters a sense of connection, and it makes more comfortable. Sense adds a sense of comfort. So usually it's done in the initial phase. You can say that um, since we are trying to build that connection with that machine and human, so we want to build that comfort level, we want to set the stage for further communication, we would usually prefer the parallel empathy. Then comes the reactive empathy, which is the example I gave, it is the exact opposite. So it involves responding to users' emotional cues in a way that aims to alleviate or address their emotional. We want them to stop experiencing that feeling. We want, okay, let's go for a party, let's go out for a dinner, you will feel better. It's like reactive. So it focuses on actively influencing. We want to influence that person and modify the user's emotions for a desired outcome, such as reducing distress or enhancing a positive effect, right? For instance, if a user expresses frustration or anxiety, a system employing reactive empathy might respond with calming techniques. Calming techniques. Then there's another way, like, oh, what happened? This my friend of mine said this thing to me. And one way is, if we react in this situation, if we react parallel empathy, if we show, then it will just escalate the situation. Oh, let me join you in the fight. We can't do that. We want to minimize that negative impact. So we would prefer this reactive empathy. Um, Problem solving strategies or uplifting messages to help alleviate the user's negative emotions and promote a more positive emotional state. So the answer is D,
Yes, it's the D.
parallel empathy and reactive.
Mhm.
Okay, what can be the correct order of stages? Okay, this question is actually related to the case study that was there in the lecture course content. There was this paper by Bagheri at I don't remember the exact name of the paper, but yeah. But this can be the generic generic sequence of how an autonomous empathizer can work. So, what can be the correct order of the stages? Understanding target's perspective or the emotion, detect the target's affective state, generate an empathetic response to that emotion. C.
It's C.
213, you're saying. Okay.
Yeah.
Okay. Let's discuss. It's the correct option.
Mm.
Um, so the first step, of course, will be detecting how the end user is feeling right now. We can't just tailor anything. We want to respond accordingly. Firstly, we need to sense. So detection is the first step. The stage involves various sensors or data sources to recognize and interpret the emotional state of the user or target with whom the empathizer is interacting. It may include analyzing facial expressions, voice tone, physiological signals, other behavioral cues to determine the emotional state of the user. Now, understanding the target's perspective of the emotion is the second step. What it means is that once the if affective state is we have detected, once we have detected the affective state, the empathizer seeks to understand the perspective, the context information, or the experience of that emotion. Perspective. This involves considering factors such as context of the interaction, users' past experiences, specific triggers or reasons, right? Then comes the, for example, let's say you're talking to Alexa, and suppose Alexa is very smart and it adapts accordingly. So I will say, hey Alexa, I'm not feeling good today. I'm in a very bad mood. So Alexa will say, oh Akanksha, what happened? Then it can detect using that text. I said I'm not in a good mood, so she will detect. Then um, understand what happened. Maybe I will tell I had a fight with my friend. So this is the perspective taking. What was the situation? Why am I feeling that way? So this can be used as a context information, right? Then we we generate an empathetic response. Oh, don't worry, everything will be fine. So that will be more like a comforting words, comforting words. So that's how we generate an empathetic response to that emotion. Okay. So based on the detected affective state and understanding the user's perspective, the empathizer generates an appropriate empathetic response. This response aims to acknowledge, validate, or address effectively, whether it's through verbal communication or gestures or expressions or other forms of interaction. So we can see that this is the proposed methodology. The first module is the emotion detection module. Okay, let me highlight. Then we have some observations here. Maybe facial emotion recognition was there. We have these observations. We determine the emotion type and intensity. Then there's perspective taking module. This is number 2. Okay. Then there is
So, what is robots' affective states? Perspective taking module. I mean, we're trying to find out the background or
yeah,
considering
yeah.
the background contextual information. So, what is this robot's affective state? I mean, the robot generates something or what? I mean,
Um, I will have to go through the paper exactly, but it looks
okay.
like, yeah.
I mean, what is the outcome of this perspective taking module?
So it can
Uh,
add the context information
okay.
because, yeah, because
Hmm.
that's the main motive of taking perspective. Also can be, now that I look at this robot's effective state, maybe there might be something that uh, previous information from the
Yeah, yeah.
robot.
Past experience,
Yeah,
taking into account
exactly.
all the past
Exactly,
information. Yeah.
exactly. So it can be something like how can we deal with these kind of situations if a user is feeling that way, might be this might be the best response. So it can be like that kind of information, and with respect to the user's context also we want to embed that user's affective state. That might be there, but I'll have to confirm that. So the third is the empathetic behavior provider module. So again, we if so empathy type we want to determine if it is weak. So weak emotions or normal, neutral. So weak emotions can be positive and negative. If we are experiencing um, like I'm neutral, I'm calm, then you can also respond in a calm way. Like the agent can also respond in a calm way. If even if I'm like sad, uh, I can show sympathy. Okay, oh, it's okay, everything happens for a reason. So it's also in a sad tone, but it's parallel empathy. So that's when we usually we go for parallel empathy when it's weak or normal. These emotions are spotted. Let me use another color. Okay, and if the emotions are normal but negative, so we want to counter the negative thing, right? And if it is very strong in any sense, if it is very strong, we would like to calm that down. We want that to be more neutral. So we want this reactive empathy. So I hope it makes sense, but yeah, that's the overview of these.
Yes, yes, that's fine. Yes.
Yeah,
Hmm.
so 213 is the correct option. Okay, so what type of empathy is used for subtle or positive emotions? Reactive, neutral, parallel, emotional. See, parallel empathy. Yeah, it should be parallel. We just saw that uh, a happy response from my side should result in a
Will
happy.
be happy. Yes, it's happy. Hmm.
Yeah. So the machine, if they also say something in a happy tone, that will be very nice to have a conversation with. But if it is reactive, then it might want to maybe calm me down, or even like react in a very different way at this moment.
No, if it is negative, then in that case, it has to be reactive or again
Yeah,
parallel. I mean, a positive is parallel, that's fine.
yeah,
But when it is negative, it has to be
reactive.
what? Reactive.
Yeah, and also in some cases,
Hmm.
we can see it like this. If it, even if it is a negative emotion, but the excitement is less, arousal, valence arousal is there. Valence is negative, arousal is suppose very less. So it is more of
Yeah,
a
arousal can be positive or negative. It depends.
high or low, high
Oh,
or
yeah.
low. Yeah. So if it is a low arousal state, but with a negative emotion, maybe I'm thinking about something in the past, or
Then
like,
parallel empathy. Huh?
yeah. So
In
we
that
can
case,
also,
parallel empathy. Yeah.
exactly, we
Hmm.
can also respond accordingly. We should not counter that thing, because I'm
Mhm.
thinking about, say, suppose a person is having personal loss or something. They are thinking about that particular person that they've lost.
Yeah.
We should sympathize, we should
Yeah.
not
Yeah.
show
Yeah.
happy emotion,
Hmm.
right?
Hmm.
So that is one catch here. And if I'm feeling negative emotion with high arousal state,
Yeah, like angry and all, then in
angry,
that case, they have to, you have to
exactly.
pacify the
Yeah,
situation.
we want to counter that emotion, we want to calm it, bring it down. So that's the differentiating factor. So the answer is yes, this reactive. Again, I'll read this out. Parallel empathy, we know that it's usually used for the subtle, positive emotions. Example, um, we have this a virtual assistant to seek assistance with the task. If the user expresses satisfaction or happiness with the assistance provided by the assistant, they should respond parallel empathy by acknowledging the user's positive emotions and expressing similar sentiments. Now, it can involve using a cheerful language, upbeat tone of voice, positive gestures, convey empathy and reinforce the positive emotional experience for the user. Now, it helps in more fostering a more supportive and empathetic interaction environment, enhancing user satisfaction and engagement with the system. So, it's the parallel empathy. So, I should actually write that down. If um, here I should write it down. So, in case of negative emotions, if high arousal might want to counter
It's
this thing,
reactive. Yeah.
yeah, so it can be reactive. But if we want to, we might want to sympathize, so it can be parallel.
Parallel.
Example also, I'll write it down. Example is angry and frustration, and this can be sad, gloomy, like that.
Gloomy. Yeah. Hmm.
So yes. Okay. How is emotional security defined in the evaluation of empathizers' responses? The level of confidence and comfort felt by the user, the emotional state of the empathizer, the number of facial expressions displayed by the empathizer, the amount of time spent in the interaction.
Level of confidence.
Yeah,
Emotional security defined by the, okay.
yes.
Hmm.
Because we are talking about the evaluation. Now we have talked about how the autonomous empathizer should behave. But if it is behaving in a certain way, how do we determine that okay, this is behaving as per it should like behave, right? How are we going to evaluate? So these are some metrics, some measures or some parameters
And there are
available.
performance metrics available, so which the evaluator makes use of to find out how good is the
How good is the
empathizer. Yeah.
system? Because we can't model this objectively. There can be no accuracy as such, right? Because there is no right or wrong in this. This is more on some level of like good or bad, if you think about it. This is more vague in the sense it's not that defined, well defined concepts. So but we have seen
It's always there is no quantitative
exactly,
measures, no? It's
exactly.
qualitative. Yeah.
Yeah, that's the
Mm.
word I was missing, quantitative.
Mm.
But we can use some ratings or user feedbacks on certain parameters, that okay, this system was okay, but when I was expecting this kind of behavior it deviated or something like that. So there are so many parameters that can be there, and one is emotional security. Of course, when you want to interact with a machine which is being emotionally which is behaving emotionally with you, you of course you will want to you expect certain kind of comfort level talking to them, right? So that is what emotional security is. It refers to the confidence and the comfort experienced by the user during interaction with the system. It reflects users' perception of safety, trust, emotional well-being while engaging with the empathizer. So, example, if a user feels emotionally secure during interaction with a virtual assistant or a robotic agent, they're more likely to express themselves. For example, if we talk about this empathizer, we can use these kind of empathizers in context of therapists. Some people don't go to therapists because it's a taboo. Mental health is still not that widely. Uh, People don't like to talk about it, so many people just don't visit the counselors. One alternative can be these kind of autonomous empathizers, which can talk to you and then provide feedback, and people will not shy away. But one concern can be that would I be able to tell them whatever I am feeling, or my past uh, secrets, or uh, the reasons why I'm experiencing this stress and all. Can we be that open with that machine? We want to feel comfortable. We want to feel comfortable while sharing this personal information and all. So again, if a user feels emotionally insecure, they may exhibit hesitancy or discomfort in their interaction with it. They won't come back interacting again with the system, right? So it helps in assessing the effectiveness of the empathizer responses and creating a supportive and trustworthy interaction, which is crucial for fostering positive user experiences and building long term engagement. If we want a product in the market, we want to build long term this engagement with the product, because of course we want it to sustain. It's not like if people are not liking it and then we have to withdraw that. So yeah, the correct option is the level of confidence and comfort which is felt by the user during interactions. So, which of the following can be parameters for evaluating empathizers' target interactions? Social presence, engagement, accuracy, trust, recall, and precision. Do you want to answer, ma'am? Okay, I'll go on with the discussion. So there can be multiple evaluation metrics for these empathizers, as we discussed. We don't have anything like quantitative. We don't have the true labels. We don't have the predicted labels. There's no such thing as labels. There's no such thing as good or bad. It's more of a qualitative thing, right? And how are we going to take the feedback from the users? It's like, um, you can, after the conversation we can have a Google form. You can have 5 options. You can have Sam mannequins, if you remember Sam mannequins from the very initially, in this course.
Yeah, some mannequins will be good.
Yeah, yeah, that will be good. How did you feel interacting with this agent? How comfortable you were sharing your information with this agent? So we can, detect, okay, on a scale of maybe 1 to 4, what was their score.
Yeah.
So then we can average those scores, and
So
that's
this
how.
is social presence, engagement, and trust.
Yeah. So
These are essential, I think, no?
yeah,
For this empathize. Yeah.
exactly. So
Mm.
let's just read these out.
Mhm.
Social presence is actually, perceived as a social entity. Okay, the extent to which the empathizer is perceived as a social entity by the user. Um, it measures a system's ability to establish a sense of sociability and relatability during more like um, for example, now Alexa and Siri, when we talk about them, it's more like, we kind of think them as a lady. Like, okay, I'm talking to Alexa. You know what Alexa said today. So this is more like a social presence is there. In everybody knows Alexa. Everybody knows Siri. Everybody knows Google. What? No, everybody doesn't know either, I think. But anyways, so yeah, second parameter can be engagement. So engagement, it evaluates the level of user involvement while you are interacting with that chatbot or that tutor or whatever the agent be. Were you actually engaged, or were you just sitting because you have to complete the task? So if you're actually engaged, that means our agent is performing really well. It is developing some, it is showing some good content, and if it is able to manage, if it is able to grab your attention, that's a very nice thing, because it's behaving as per it should behave, right? So it reflects how captivating or engaging or the immersive the interaction experience is for the user. Now then comes the trust factor. Trust measures users confidence and reliability in the empathizer responses and actions. um, if so, for example, there's this chat GPT. I ask him many questions and it gives me answer, and now the trust has been built so nicely that I don't even, although it can make mistakes, but we trust the output. We trust the output of that agent, and um, this trust has been built. So like it is a, that's why people go back to ChatGPT, ask another question. If it is giving wrong answers consistently, or it is not behaving according to the way it should, then that's another issue. That's I won't go back, I would explore other options. So we want to, the system to be trustworthy, and the system's ability to foster trust, and not just, it should be academically right, like I'm asking a question, it should solve it, but it should also be more emotionally aware and emotionally or empathetically aware. What should I respond, how should I respond, again, according to the expected behavior. So credibility, trust, these things should be built in its interactions, which is essential for building a positive user relationship. Again, now talk about, if we talk about accuracy and recall and precision, these parameters are, we want to, we know that okay, this is the absolute truth, this is the ground truth, and this is the what I have predicted. So here we are not even dealing with the probabilities, right? It's more of a subjective opinion. You're writing, okay, I did not feel good talking to that, but another person may be like, yeah, I felt really good. So it's more of a subjective feedback rather than an objective measure of accuracy, recall, or precision, or how many true positives or true false negatives or whatever. So this is more.
One thing I'd like to ask, actually, the while the robotic empathizer, suppose, while building this thing, this social presence, engagement, and trust, these are, I mean, how do you sense all these things? Is it through different sensors or through question, I mean, these interactions and all? Is it a software thing, or, I mean, how it's done really?
So maybe in case of
Engagement, it's fine. Suppose you are showing some video kind of thing, and you check how much the user is involved, what it is doing, whether it pausing back or staying or simply skipping the things and all. From there, you can find out the engagement. I mean, involvement kind of thing.
yes, you can use the
The
camera sensors for engagement. Yes,
cameras, but again, the trust. How do you I mean, define
define
this?
it right. Like
Yeah,
so, these are actually very vague concepts, as we know. Like
yeah,
even emotions
yeah.
are very vague, right? So
Yes.
trust is something. Like
Through questionnaire something can be done. Yeah,
yes,
but
yes.
again, you have to take a lot of users to arrive at any conclusion. Otherwise,
Exactly. We
uh,
can't generalize these
how
things.
these tests are done actually on the basis of, I mean, in a large scale, or I mean, I mean, how can we be sure that yes, this is the one which can sense trust? I mean, if this is the way somebody answers or interacts, then it can be said that yes, it's trustworthy or something like that.
So one thing that I can think of is that, for example, there is uh, some robo which is designed to pick up something and just pick from point A and drop at point B. For example,
Hmm.
you can say the
Hmm.
drones delivery that
Yeah,
Amazon
bronze
provides.
delivery is fine. Yes, they have to be very precise. The location is to be
Precisely.
precisely
Yeah.
defined. Yeah.
So in those kind of agents, it's just another one dimension is there, I know,
Hmm.
but in that sense, if we talk about trust, would as a customer, so Amazon can float a form after every purchase. Would you trust your delivery, if we like, would you prefer your delivery through a drone? If people say no, then there is no trust in that. Or maybe you can design the questions. Of course it will be through a feedback form or a survey or something like that, because otherwise we won't be able to gather the data, right?
Yes,
We
yes.
want as many people as possible, because the more the sample size, of course, the credibility of that score or that, it is going to be much better, right? We want more people to participate and use that to
Yes,
interact.
yes, exactly.
Yeah. So these things, I think, they require very, like, huge number of people interacting, and then we can finally, as a product, if you want to launch, then you have to build that trust.
Yeah, lot of large
Yes,
scale experimentation
yes,
are
yes,
required.
yes. And we can collect the data through questionnaires, feedback forms, whatever, and verbal feedback, so one example is I shopped personally from a website, and I returned a product, and then personally, person, like, called me. There's this from their help center. They called me, they asked me, okay, this product you returned, can we have that feedback? Okay, why are you not um, buying it, or why did you return it? So I explained
Yes.
them, okay, it is not designed for, my height is short and like that, that's why I returned. If you add something like this in your collection, then I might buy the same design again, but the design is nice. So I gave him 3 to 4 points that they should work on, or whatever works for me and what is not working for me. Similarly, in these empathizers and these affective systems, we can also provide the feedback in that form. For example, if you want to check whether the product is people are finding trustworthy or not, you can ask people, would you prefer your package to be delivered via drone? If they say, okay, drone might drop it in between and it won't be safe, then you can say that most people are not liking the drone delivery system. So maybe we it's not that trustworthy yet, but we want to more, like, more people to believe, and somehow you can show through campaigns or something that, okay, we have built a good product and it won't drop your package in between. So these kind of things, if we talk about now in the affective domain, suppose a robo is there, and there's a robo is designed for interacting with old age people. For there are robots in Japan which are designed for companionship, because old people are there, right, and they do have anybody to interact with. So these robots can be used to interact. Now what? Now they can the makers of that robot, they can ask from the user, the old man, that okay, sir, did you find it nice? What if you say something like this, and how is the robot designed?
Yes, yes.
So it
Is
respond.
there any such product available in India? I mean, designed in India, like the way only to interact with old people, like a companion, as
Companionship
you
and
said.
all.
Yes,
I don't think so. I am not aware of any such, but I've heard that there are robots in
yes,
Japan.
yes. There are robots in many
Yeah,
robots. Are there. Yeah.
yeah. Even the restaurants and all, and they just
Yes, yes, yes. Restaurants
yeah,
also there. And during the COVID time, also in while drug delivery and for other purposes, they used them.
yeah. So
Yeah.
I know that there is no effective component in that, but I just wanted to make a point that we can get that
Yeah,
feedback.
yeah, this can be designed because
Yeah,
a lot of scope exists right
yeah.
now.
So you can hold.
Yeah.
Yeah. Please
Mhm. Old and young also, in young adults, I mean in university students, to detect all those affect related issues in the beginning stage. If early detection is possible, then it will be really helpful.
Yes. One example, another that we were discussing, like auto tutor.
Hmm.
Suppose I create a auto tutor with the content being displayed in CS domain, right? And so one trust question can be: do you think the content is valid? It's validated. It's correct. The correctness can be one parameter. The how that it's behaving, or if you are in case of therapy sessions, if you are feeling like okay, I'm sharing my personal information, how is that information being processed? Because it is a model, your information will be stored somewhere, it will be retrieved in order to respond accordingly. So is that my data safe? Is my data safe? So these things can help you like build trust factor in this affective system, because affective system will definitely capture your data, which personal, maybe your face, maybe your, if you are dealing with images, then you might want to capture maybe heat maps, not the RGB image, maybe other what is that
Yes, it maps
normal
will be. I
images.
mean, there is no way to recognize directly.
Yeah,
Otherwise, this comes again ethical violation
ethical,
will be there. Yeah.
exactly. So this is more of an ethical thing, a trust
Mm.
thing. Engagement, we know social presence can be like how popular that is, or do you have you ever heard about this product before? And
Yeah.
if it is established, if it is well, like people are using it, then it also adds on the trust. Okay, many
Mm.
people have used it, this might be a good product, I can also try. So it's more like marketing and all, so many things can be done. So
Mm.
these factors can be there. So I think we've covered these. Oh, yeah, I think all we've covered, right? So yeah, so the answer is 1, 2, and 4. 1, 2, and 4. So yeah, okay, that's it for this session.
Yeah.
Next
Mhm.
session will be on 9th of April. And thanks for joining the session.
Thank you so much.
Uh, okay, thanks. I'll hope to see you in the next session as well.
Okay, okay, yeah, definitely.
Bye. You might leave.
Thank you.